Greetings, everyone. My name is Belva Anastasia Florence from L303, and today I'm going to present about the pigeonhole principle. So now I'm going to move on to explain the principle itself. If n pigeons are assigned to m pigeonholes, such as that n is more than m, then at least one pigeonhole must have two pigeons. So if there are n plus 1 pigeons, then pigeonholes, then at the very least some pigeonholes must have two pigeons. So this is an example from the principle that I got. In example 1, there is only one circle which represents the pigeons in a square which represents the hole. And the second square only has one circle, which is still fine because the last square or third square has two circles, which also means that the principle of at least one pigeonhole must have two pigeons is true. Let's start with the second example. With the second example, the first square has two circles, which is also still correct because at least one pigeonhole has two pigeons, and we have already corrected with this one. Same as the second one that also has two circles in a square. Because the at least one pigeonhole must have two pigeons is only an at least, not a more than, which is why it's correct and why the third square can be empty. Now let's move on to the last one. The last one here only has one square filled and the two others not filled. But it's still correct because there's one pigeonhole that must have at least two pigeons, and we have four pigeons here or four circles here, which is still correct because there's one square that is actually filled with more than two or two pigeons. Next, we're going to move on to the example question. If there are 13 students of a class, prove that at least two of them will have the same birthdays in the same month of the year. Okay, so we have 13 students and 12 months in a year. And each student can be considered as a pigeon, and the months will be considered as a whole, which is the pigeonholes are the circles and the students are on top of them. Now, since we have more students than months, according to the pigeonhole principle, at least two students must share the same month. Therefore, we can conclude that two students will have birthdays in the same month of the year. And that's example question 1.
So now I'm going to talk about the extended pigeonhole principle. If n pigeons are assigned to m pigeonholes, such that n is more than m, in brackets, the number of pigeons is much larger than the number of pigeonholes, then at least one pigeonhole contains n minus 1 divided by m plus 1 pigeons. So this is an example question. 50 babies are born in 7 hospitals. Prove that at least 8 of them are born on the same hospital. Okay, so as you can see, the n is 50 and the m is 7. Now let's start counting. We're going to start by writing the formula, which is n minus 1 per m, and then we bracket it, plus 1, which equals to the m is 50, so 50 minus 1 per 7 plus 1. Okay, we're gonna count. So 49 divided by 7 plus 1. 49 divided by 7 is 7 plus 1, which answers to 8. So therefore, we can prove that at least 8 of them are born on the same hospital.
And now we're going to move on to an example question 3. Mr. X picks 5 numbers from 1, 2, 3, 4, 5, 6, 7, 8. Prove that 2 of the numbers will add up to 9. So the available numbers that we have now are 1, 8, 1,8, 2,7, 3,6, and 4,5. So there are now 4 groups, which can make the M, which is the pigeonholes, 4, and the N, which is the pigeons, 5. So we can see that N is more than M. Therefore, the pigeonhole principle is applicable. And we can see here that It is correct because at least two of the picked numbers must belong to the same pair, which in pigeonhole principle is two pigeons belongs to one pigeonhole. Thank you for listening to my presentation. God bless you.